Good afternoon, everyone. Mr. Cagurol again. Welcome to Physical Science class. And we're going to talk about the third quarter module 2 topic. Your module is titled Synthesis of Artificial Elements. This module has a MELC, which is to explain how the concept of atomic number led to the synthesis of new elements in the laboratory. So you're going to identify the new element synthesized in a reaction. Then you're going to explain how the new element is identified. So if we are going to talk about this type of topic in which an artificial element is created, or an element is created, a new atom is created, then we're going to go back to nucleosynthesis. Nucleosynthesis is the production at a cosmic scale of the species of chemical elements from perhaps one or two simple types of atomic nuclei. So we have already identified that during those early days of the solar system, we begin with two elements, hydrogen, H, and another element which is helium, He. So hydrogen 1 has this element, this symbol, the atomic symbol, the superscript signifies the atomic, the mass number, and this one is the proton number. And your helium has 4 nucleons and 2 protons. How do we identify the element? We need to take note of this number here. 1 signifies it has only 1 proton. Therefore, any element or any atom with 1 proton will always be hydrogen atom. Let us say you have another isotope of hydrogen, which is deuterium. Most often, the book usually uses the small letter D to denote deuterium. And for this one, H1, is called prosium. Then, of course, the third one, the third hydrogen isotope, is called tritium. So these are the isotopes of hydrogen. If you're going to add one more neutron, then your element will be very unstable and it will no longer stay as a hydrogen atom. So we talked about earlier, we talked about nucleosynthesis. So these are the atoms in which the whole universe started. So during the time, about 300,000 years after the Big Bang, the universe has ample of this, hydrogen and helium. So how is your atoms, the next succeeding atoms, created if you only have 2? So paano siya nabuhat, paano namugna si lithium, si beryllium, si boron, and si barium, si carbon, and the rest of the elements, there are 118 of them, and more is still being produced. How were they created if you only started with hydrogen and helium? So, first, your hydrogen atom, let us try to remember in our chemistry that your hydrogen atom looks like this. 1 proton and 1 electron. So this is prosium. Your deuterium here is 1 proton, 1 neutron inside a nucleus, then a electron outside. Then your tritium here, you have one proton still, because if you're going to add one more proton, it's no longer hydrogen, but it's already helium. So one proton, then since you have three nucleons, there are three particles there in its nucleus, therefore, you will have to add one more neutron. So you have two neutrons, one proton, and this is your tritium. And they are tightly bound, which formed a nucleus. Then you still have one electron. So they are almost the same. They are the same in terms of the number of protons. One proton, and also one proton for tritium. While, again, this is protium, this is deuterium, and this is tritium. You have only these three isotopes. Your hydrogen cannot carry more than three isotopes. So, they have different number of neutrons. That's why their mass number are also different. So, if you're going to start with a proton, you have a proton here, nucleosynthesis will only take place inside the nucleus. So, wala na ilabot si electron. So, erase. Wala sa siya ilabot. Anyway, it will be captured later by your element. Then, another proton here. This is another protium. This is protium 1. And this is another protium. Then, if they're going to hit each other, they will merge. And one of your proton will be converted into a neutron. So, you will have proton. This neutron here, proton here, will be converted. Your proton will be converted into a neutron plus a positive beta particle. Therefore, your proton here will now be converted into a neutron. So, wala na siya sign. Wala na siya positive charge because the positive charge is already here with a beta particle. Now, you will have one proton and one neutron. So, this is no longer a protium, but instead, it became a deuterium. And again, this will capture an electron, and they bind the electron, and they form the deuterium atom. So, same thing will be applied. You have deuterium, one proton, then plus one neutron. If you're going to merge it together, because a star has a lot of gravity, that the elements are being they are being drawn together. Therefore, pressure is greater, and there's a very big chance that they will hit each other. So you have a deuterium D. Then you also have a protium. If these two merge together, then your proton here will again be converted. Your proton will be converted into a neutron plus a beta particle. So, your proton here becomes a neutron already. So, you have one proton, which is this, one neutron, which is this, and this proton here was converted into neutron. Therefore, it becomes a neutron here. then it gives off a beta radiation. So you have already 1, 2, 3 nucleons. So you have now a tritium. This is tritium 3. So what is common between them? Protium, deuterium, and tritium. All of them has only one proton. So the number of protons dictates the type of element that you have. So, pwede pa ba niya siya magpadayon? Let us say you add one more proton there. Then if you're going to have a tritium, or we're going to use an equation. You have tritium plus a hydrogen atom without using the illustration anymore. Then you will have 4 nucleons already because this one will be added. So by that time, if you're going to add, so again, this is your reaction. You have tritium here plus a protium. Then you will have, let's erase all the letters first so you will not be confused. So what will it give? What element will be given? Plus what element will be, plus energy, gamma radiation. So what energy is produced here? What element is produced here? So let us convert this nucleosynthesis equation into a mathematical equation. Okay, mas dali. So we'll just copy 3, then 1, plus 1, 1. Will give you something. So we'll add all those nucleons first, then we'll also add this one here. So you have 4, because 3 plus 1 is 4, then you have 1 plus 1, you have 2. Then remember that this is proton number, or this is the number of protons. Then we go back to our periodic table. What element has 2 protons? It is helium. Therefore, your equation will now become like this. So you have tritium plus protium will give you helium atom with 4 nucleons plus a gamma radiation. So this is an example of nucleosynthesis. I-pause lang ha. Okay, let us say you have 2 helium atoms. You have 4 nucleons for helium and 2 protons for helium. Then you're going to add another one, which is another helium. What element will be created if it only emits a gamma radiation? Let us try to remember the different types of radiation. As you have learned in your previous sciences, you have alpha, which is the same as your helium atom. You have beta, which is your positive electron or positron, or it can also be a negatively charged particle, a high energy negatively charged particle, which has either negative or positive. And you also have gamma radiation. This one usually converts neutron to proton or proton to neutron, while this one is a type of electromagnetic wave, which is a type of energy. So, what is created? So, again, as we have done, we're going to convert that into a an equation, a mathematical equation. So we'll erase the letters first para dili kayo siya confusing. So you have 4 nucleons, then you have 2 protons, plus 4 nucleons, and plus 2 protons will give you something plus, since gamma radiation, wala siya proton, wala po siya neutron. So, wala siya i-add. So, let's just mark it as 0. So, we add together the nucleons. You have 8. Then you also have to add together the number of protons, which is 4. Then you will create an element with 4 protons and 8 nucleons. So what element would that be? So you will have, if you're going to go to your periodic table, the one with atomic number 4,